Welcome to CamLogic's Tech Tuesdays. Today's presentation will start in 1 minute. Hello everyone, welcome to this week's edition of CamLogic's Tech Tuesday. My name is Rob Carver and I'm an Applications Engineer at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar. And today's topic is Manufacturing Part Setup Best Practices with an XCAM Part 1. CamLogic is a leading provider of Product Lifecycle Management, or PLM solutions, 3D scanning and rapid prototyping technologies and services to help companies design and build products, improve processes, reduce costs, and maximize profitability. We provide unparalleled 3D engineering technological solutions along with the services and support to ensure our clients' success. CamLogic is a Siemens PLM solution partner. We offer the complete C software suite including NX, Solid Edge, PMAP, and Team Center. We also carry a complete array of 3D printing hardware and services solutions, including the 3D Systems ProJet series and the Z Printer series, the most affordable color 3D printers on the market. 3D scanning technologies rounds out our trifecta of engineering solutions, from the state-of-the-art hardware like Romer Absolute Arm, Shape Grabber, and Z-Scanner, and cutting-edge time-safe inspection or reverse engineering software products from Geomagic and RapidForm. CamLogic is here to provide a variety of solutions to meet your business challenges. We also offer professional, high-quality, in-house scanning services. In this demo, we'll focus on the file structure of CAM setup and the associated benefits, setting up various coordinate systems, or MCS, necessary, the use of synchronous modeling and the reuse library. Setups can be as simple or complex as the programmer desires. NX offers the flexibility and control necessary to compete in today's global manufacturing environment. The small job shop doing one-offs will benefit just as much as large corporations setting up production runs by the workflow practices offered by NX. So let's go. What we have here is a simple part. It's a casting. I would assume that it's a casting. Typical geometry, simple geometry that we might find in any kind of machine shop. We have our assembly navigator up. We can see that the demo model is here. One of the first things we really want to do is go ahead and measure this thing, see what kind of size we've got. So we're going to go into analysis, do a length on each one of these edges. That edge is 80 millimeters. That one's 125. It's roughly 5 inches. That's 300, so it's a fairly good sized part. This kind of thing might be necessary to figure out how you're going to fixture it, what size cutters you need, that sort of thing. We can cancel out of that. One of the, as I said, this is a casting, so eventually we're going to have to create our casting. You can use a customer's, if the customer will supply a casting for you, a casting part model for you, that's great. We're eventually going to have to make our own. But before we do that, we're going to create a new part file, manufacturing part file. In the old days, we used to just go right in and start creating our manufacturing environment right in the part itself, but that's really not the best way of doing it. There's a few advantages to doing it the way I'm going to do it here. So what we want to do is we go to File, New. It's going to open up our file creation dialog box. You see we have our model, drawing, simulation tabs, inspection. We're going to concentrate on the manufacturing tab, obviously. Okay. We're going to reference our existing part. Here's the name of the part down here. We're doing a general setup. We could also do a die mold or a turning setup, mill turn. These we'll set up the environment specifically for these kind of tasks. But we're going to just use a general setup. And notice that setup_1 has automatically been added to our part file name. You also want to make sure that you have the folder that you want to store this part file in selected. This is set up the way I want it, so I'm going to hit OK. All right, now I have my part file set up. Go to the resource bar first. You see that my model has been added to as a component to the assembly demo model 1 setup 1. One thing I should mention before we go much further, I'm using full screen mode here because I normally work on a laptop. If you click this box up here, that'll take you back to a more traditional NX view with your icons. Again, this works well if you're on a large workstation or with a large monitor. As I said, I'm working on a laptop, so I kind of like the full screen mode myself. It gives me a little bit more real estate. And you notice that my toolbars and my menu bars kind of fade in and fade out as my mouse goes up towards them. So that being said, let's continue on. I want to create, as I said, this was a casting, so what I want to do is create my casting model. So I'm going to go to Assembly. In order to do that, we need to create some wave link geometry. So I'm going to go into Assemblies under, if I hold it there, Wave Linker. Gives me the option, and I'm going to select this body. I'm going to make sure it's associative and click OK. Now when I go to my assembly navigator, I can turn off my part file, but all that's left is my linked geometry here, this linked body. Now I can go in and create my casting model using synchronous modeling. So I'm going to go to the Start menu, I'm going to start modeling, go to the synchronous modeling tab, and you can do a variety of things. We can pull faces with these drop downs. We can pull face, move face, offset region, replace face. We can resize blends, reorder the blends, resize chamfers. I'm going to use delete face in this case. And under delete face, you have two options. You have face or hole. Now I'm going to delete some holes here. So basically all I do is I go through and I delete the holes I don't want showing anymore. Get rid of that one too. Hit OK. My face and my holes are gone. Casting typically has some extra stock on it. So in this case, I'm going to add my stock by using Move Face. I'm going to select the face I want, and my wheel comes up. And usually they got around 3-4 millimeters of stock on there. Looks pretty good. So I said OK. Select these two faces, and again, you can add about 3 millimeters of stock. You can add more if you want. Typically, it's around 3. Apply. One other thing, just for illustration, that you can do with this, obviously I can pull this around any way I want to, but if I grab this little node here I can also adjust the angle of the face. Okay. But seeing as I don't want to do that, I'm going to just cancel back out of here and it goes back the way it was. All right. I'm going to turn on my model again. You can see that I've got my stock added in the places that I need it to be added. So now I'm going to go back to manufacturing. Okay. And let's talk a minute about the operation navigator. There's different views on the this is how you control the operation navigator is pretty much the heart of NXCAM. Through it you control the different views that you have. You can either right mouse click on the white space, or you can go up here to the navigator tab, and you have these same options available to you up here. Okay. Program order view, this is the only screen where the order of the operations that you create are important. So when you post the program, this is what's going to determine how the tools and how the tool paths are post-processed. Any of these other screens, such as machine tool view, it's not really going to matter what order they're in. We're going to work in the geometry view. So I'm in the geometry view. This will pass information onto the other operations, such as your MCS, your coordinate systems, and your workpiece. So right now I'm going to start building up some of my necessary geometry. I'm going to go into my workpiece. I'm going to edit. I'm going to specify the part, and I'm going to choose my original part file. You see the three little squares come up there? Okay. Now I can select them from a list. I can select either my demo body, which is the one I want, or the linked body. But here's my demo body. That's the one I want for my part geometry. I hit OK. Now I'm going to specify my blank geometry. And under the blank geometry, you've got several options. You can do geometry, which we're going to use, or bounding block, which you can pull. You can pull that around. I think that's pretty neat. Another option that you might use in this case would be part outline, and it's just going to give you just one option to pull it around in the Z direction. There's other options in there, but right now we're going to use geometry that we created. We're going to use our casting geometry that we created. I'm going to select my link body and hit OK. Now, if something happens, you've selected too much, you can always come back here and hit X, and it deselects it, and then come back in. Okay, there's a face. I don't want the face, so I want that. I want a solid body. Okay, there's my solid body. So there's always a way to recover. And also under this mill geometry, what we want to do is we want to select our material. So we go to the little edit, the little wrench icon here, and that brings up a list of all the available materials. This list is customizable for your particular industry. In this case, we're going to select aluminum, and it shows up right here. And now I'm finished here, so I'll hit OK. So I can hide now my casting geometry, if you will, my linked body that we created. Now we got some decisions to make here. A part like this, you can make it in the vise on a 3-axis mill, and then do a put it up on a sign plate to cut these surfaces here. We could also put this on a 4-axis machine, which is kind of my intent here. In order to do that, we're going to have some sort of common reference point. So what I'm going to do next is I'm going to add some assembly parts here through my reuse library. And what this is, it's a series of parts I've created over the years, or sometimes they're commercially available. You can download them off the internet. In this case, I'm going to add a tooling ball from my tooling ball directory, and I simply grab the icon and drag it into my work environment. And that begins the assembly constraint dialog box. And under here we have different methods of constraining our assembly. I'm going to use the touch align, and I'm going to use the touch option. And down here in my preview window, I'm going to select the face that I want to touch first, and I want it to touch that inside face there. Now I'm going to touch this face here, and touch that face there, and hit OK. And that brings my tooling ball into my assembly. Okay. Now, one other thing I want to do real quick, I want to go to my assembly navigator, and I want to make sure that my reference set is set to the entire part. I know that there's a point inside the tooling ball that I want to use for reference. Sometimes if you can't select something that you know is there, it's because perhaps the reference set isn't set to entire part. So now what we want to do, I want to go back to my operation navigator, and I want to edit my MCS. Underneath the details, I want to make sure that I'm set to main, because what this is it automatically brings my initial MCS, my machine MCS, in on my absolute work position. But I want that up on this tooling ball. So I'm going to specify my new MCS. I'm going to use the dynamic option and existing point. I'm going to change my rendering style to static wireframe so I can see the point. There it is. I hit OK. I see that my coordinate system tool is up there. And OK. And now my MCS is now up on my tooling ball. Okay. Now, while I'm here, I'll add a little bit more geometry. There's different methods of adding this geometry. You can either do insert, and it brings up the create program, create a tool, create geometry, method, operation, or you can go to your operation navigator, right mouse click on the object, in this case the workpiece, and insert. And I've got the very same options available to me here. Okay, so I'm going to once again insert some geometry. I want to create another MCS coordinate system. This time I'm going to call it part. I'm going to name it. Yeah, I've got to get my caps lock on. Okay. I'm going to, this time under details, I'm going to leave it as a local coordinate system as its purpose. I'm going to use the main MCS as a special output for rotation, and I'm going to use fixture offset number 1. Now I'm going to specify my MCS, and again, I'm on that point right now, and I'm going to just go ahead and accept that. Hit OK. And I want now, I want another coordinate system that I'm going to call angle. Okay. And I'm going to, again, go into my details, leave its purpose as a local special output. Use NCS. This time it's going to be fixture offset number 2. And I'm going to specify it. And instead of it doing anything other, all I'm going to do is just grab one of these nodes on my coordinate system tool, and I'm going to just simply rotate it 45 degrees that I know those angles are at, those faces are at. And I'm going to hit OK and accept that, and OK. Now I can create some extra geometry. It looks like I have a little bit extra time. So I'm going to go in and add a little bit more geometry. This time I'm going to go underneath NCS part. Again, I'm going to go to Insert, Geometry. And I'm going to select, this time, an area to mill. And I'm going to mill the top face. Hit Apply. I'm going to specify my cut area is this top face here. I'm going to hit OK. Let me change my rendering style back to shaded with edges. Okay. And you can see the little flashlight now here. Now I can show it. Okay. And if I reselect it here, it highlights it just to show you what I've selected. Okay. And we're going to hit OK again. Now I'm going to select it. I'm going to do it again. Mill angled face. Is my name. Hit OK. Specify the cut area. I'm going to select this face, select this face, hit OK, and OK. You can see how this is how we begin to build our geometry. I can again insert some more geometry. This time I'm going to select the holes on that angled face. Okay. Drill geometry. I'm going to call this thing angle. Specify the holes. Select. I'm going to select the generic point, arc ellipse, sphere, and I'm going to go in and select 4 holes on the angled face. Okay. You see it highlights them and gives me, it's kind of hard to see, but you can see that it's got a little 1, 2. And it's a good idea to check this too, because sometimes you might double click on a hole. You might end up with 3 here and then 4 or 5 right here. So I mean, it's a good idea to check how many points you've got selected. You can always go in and omit one. With omit, highlight that, and delete one of them. But I hit OK. I'm going to specify my top surface, and again, it's the face that we selected earlier. OK, and OK. You begin to see how we build up our geometry. Okay, and so far we haven't created any operations or anything else. But once we do start creating the operations, it'll be a simple matter of selecting the geometries and the tools and a few more mouse clicks, and away we go. I'm going to do one more set of holes, and then I will be just about out of time here. So once again, I go to the coordinate system I want, insert geometry, and select some holes. This time I'm going to call it drill geometry capped. Okay. Specify the holes. Wrong button. Generic point. Whoops. Okay, I see a little small number 3 there. And I hit OK. Specify the top face. And OK. All right. I'm going to stop there for the time being. And next time we pick it up, we'll continue on. We'll have it a little bit further advanced. But you get the basic idea of how do you create your geometry, how you edit your MCSs. So, to recap, we talked about synchronous modeling in the reuse library, MCS setups, and the benefits of using the NX workflow. Here at CamLogic, we offer a large variety of hands-on instruction, intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training labs located throughout the Midwest. For more information or to register, please visit our website. Websites are usually posted within 24 hours, and you can check it out on YouTube. And thank you for joining us today. If you have any questions, please feel free to email me or call me at any time. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. This concludes today's edition of Tech Tuesday. Thanks again for tuning in, and have a great day.